Today I'm going to study Blender's source code, and what I'm trying to do is to understand how they do Bezier curves, so I can convert to Godot and create line 3D on Godot. So I'm going to try to study from all the functionality related to creating the 3D curves on Blender, and then try to extract the algorithms that they use to build the vertices and create line 3D on Godot. But before I start today, I want to recommend this podcast here because everything that he talked about seems that it resonates with me a lot, and it's stuff that I've been thinking about for a long time, and I think he's on the right direction. I haven't spent too much time looking into the details yet, so based on the link here that Joe Rogan provides, you can go to the website and then they have other videos here. But I think that's what he's saying makes a lot of sense. So there are no straight lines of the universe. Everything is a hologram and is fractal by nature. And gravity is an effect, so the universe is electromagnetic. I think that's the correct view, and Einstein and quantum mechanics is wrong, and the universe is electromagnetic. So Tesla and the other guy that this guy here talks about all the time as well. I've been watching a lot of his videos as well, and I think that this path is a lot more correct than the current models we have right now, or the mainstream models, let's say. So I wanted to share this, and I highly recommend people to listen to the whole podcast and watch these other videos here. And I'm definitely gonna study more about this. And yeah, it's stuff that I'm very curious about, and I think that he's on the right track. So basically, I'm gonna watch all this other stuff. Takes more time on YouTube. I'm just gonna wait to see if it's streaming. On Twitch, it's already working, but on YouTube, it usually takes longer. So the first thing I want to say before I start is just go over this. So basically, I already downloaded the source code and then I installed, and I tried to compile without building from Git, but it didn't work. So I think that's like the easiest way, which is the way that I did, was just to follow the documentation here. Then I just cloned the repository. So create a folder, then you put this command on the folder. It's going to create another folder on that folder, which is basically what I have here. This is Blender, and then this is going to be essentially the source code. After you put after you run the git command from this path here, generates this folder, which is the Blender. Then you cd to the folder, and then instead of writing make, you have to, I'm on Windows, so I'm going to be talking for Windows. You basically run the batch file that they have on the root here. And I'm going to be studying this file now, which is the build system for Windows. I'm going to just talk about the Windows because I'm using Windows now. So I'm going to be studying this build system first. I think I'm going to have, I'm not really sure how difficult it's going to be, but I assume it's going to be very difficult because of the stuff that I've studied so far about 3D lines. So I'm probably going to have to make a bunch of streams just studying all this stuff, trying to figure out. But basically, run this file from the terminal by passing the path, and then you pass update first. So you need to call the path and then pass the argument update. And this is going to install all the third-party dependencies as far as I understand now. And after you do that, then you call the file again just with make. And I think that depending on what kind of build you want, you need to pass different arguments. So it's just like when you're using CMake, you pass the release equals to debug if you want the compiler to build the debug version, and you pass release if you want to compile the release version. And based on the way that they set things up, it's going to generate these other files on the folder one level up to the folder, to the Blender folder, where the source code is located. And this is the folder that contains all the resulting build files. If you're using CMake, the way I was used to do it on other projects is just running CMake and parsing the build path from the root directory. So it would be /build, and that would put all the build files on the build folder from the root of the directory. But based on the way that they did here, is pretty much the same. This is just the resulting files of after you compile for the first time. And then the executable is going to be somewhere, I think it's on binary here, binary debug. This is the debug version, and this is going to be the Blender, the final executable that runs the Blender program. And that's basically how it works. And then the other important thing is this other part here, which is, oh no, this is the layout. So the other one, yeah, I'm gonna go over this as well. But basically the main thing I think is on the /source or something like that. The main path where the files are located is on create source, yeah. So is from the folder, is on source folder here. Based on the tutorials I've seen so far and the documentation there, the source seems to be the main file, and this is the entry point of the application. But this path here contains this explanation of the folders and what they do. And the other thing that I wanted to talk about here, I'm probably gonna look into this as I explore there to figure out, but is the debugger. So I'm gonna step over with the debugger, and I'm using Visual Studio Code. So they have this documentation here, and the documentation is for the Linux system. And this is something that it took me a long amount of time on other projects to understand. So how to translate this to Windows, and it's not that complicated. And as far as the tested there is working. So basically they put this configuration here, and the way that it works on Visual Studio Code is that you have to create this folder called .vscode, and then you put this task.json, this launch.json files, and then whatever you put here as a task is gonna run before the executable that you're gonna run runs. So this is what happens before. So you can think about it like compilation parts of the process, and this is what happens as you execute the thing that you wanna debug. And in order for this to work, you have to change, if you're doing for Windows, and the main thing that I have to change is the type here. So the way that it works on C++ is that usually you're gonna have you can have different kinds of compilers, and different kinds of compilers are gonna work in different systems. So usually the one you're going to use on Windows is MSVC, which I think is MS Build executable. I'm not 100% sure, but it's MSVC the way that I remember. And if you compile a program using the MSVC compiler, then it's going to generate a different executable than if you compile with Clang, I think. Clang, I think just is C, but I don't remember exactly. Basically Clang is for Linux, and the MSVC is for Windows. So if you compile for the executable to work on Linux, then you're going to use GDB as the debugger. And what VS Code does is just connects uses the interface of the IDE to connect the executable you're running with the debugger on the back end. So just passing messages back and forth is the model view controller pattern, I think. So everything that you do on the IDE sends a message to the debugger, and then the debugger has the logic of what's going to happen. And that's the reason why you need to compile the executable with the debug version, because the debug version is going to load the symbols. And the symbols are necessary in order for the debugger to know the breakpoints. So if you don't build the debug version is not going to work because you don't have the symbols. And the way that the launch.json file determines this is based on the type. So this type here is for GDB. And all you have to do is just put a different type, and then whatever you put here is the path to the executable you want to debug. So just put the path, and you can put arguments if you want. And here you put the pre-launch task, which is the task you define here. So what VS Code is going to do is just going to run this task before you execute, but it's not necessary, it's just best practice, I think, because then you're recompiling each time that you run the debugger before the VS Code executes the program and then connects the MSVC debugger on the backend. So that's basically what you have to do. Just put the task here, and then this task you're just gonna run a shell command, which is basically just running make math with the debug argument. It's as if you're running this command here, but VS Code does it for you. And then after that, it's just gonna launch the executable that you have on the path that is one root up, because that's how they did the thing here. So it's basically just going to this path here. You have to get the path manually. Workspace folder is gonna be the Blender folder, I think, which is the one that you install the source code on, based on the way that they recommend there on the documentation. So that's what I have so far. Yeah, I think that's pretty much all that I wanted to say before I start to look into the source code. So yeah, I think I already looked a little bit into this bat file, but I'm gonna go over and just try to figure out how it works. So based on the way that I looked here before, I think that's what this is gonna do is gonna call another file. There's a folder here that they have that has a bunch of batch files as well. I think bat files. I don't remember where. It's probably here somewhere. And I think that what this is doing is just running CMake for you. So yeah. So it's on build files, Windows. So I guess it depends on the platform you're running. Yeah, so this is the folder that I remember. So I think what it does when you run this file is that it's gonna look for this folder and it's gonna run a bunch of functionality on this files here. So Blender dir, I assume, is an environment variable from Bash that is gonna find the root of where you install the source code. So basically the Blender folder. It's just accessing the reset variables first. So this code here, this what pretty much does is just sets everything to an empty value, as far as I understand, that the build system is gonna use probably. Just resetting the values, then it calls this check spaces in path here. Also, it checks to see if you have spaces on the directory, because it doesn't support spaces. Interesting. Then parse arguments. So here's probably, like the name says, parsing the arguments you pass. So when you pass debug here, it's going to be this thing here probably. So it's setting the environment variable build type to debug. Obviously, I don't know for sure because I'm just studying now, so I'm just gonna talk about what I think he's doing. Let me see here. So the debug just sets this variable, and here is setting these paths here. So on the other types of builds is setting the CMake path. And the way that CMake works is basically you just put the CMake list text file, and you run CMake, which is this file here, and then you run CMake from the directory that has this. If you don't have CMake installed, you have to install CMake and put it on path. And so all that putting on path means is that so the terminal is like the bridge between the code you're running and the operational system. And the operational system is the thing that allocates processes on hardware. So it's kind of like the brain of the hardware. And it serves as the bridge. So the OS is the thing that runs the processes. And it uses the terminal. You can use the terminal to communicate with the OS. And that's basically what you're doing when you're running commands. And in order for the OS to know, if you want special executables to run, so for example, if you want to run Python, the only way you're going to be able to write Python on the terminal and the terminal understand what's happening is if you put the path to the executable that you want to execute on the environment variables, because that's how the OS is gonna know. And if you put here, then it allows you to, whatever path you put here is gonna allow you to call the name of the file that is an executable on the terminal, and then it's gonna run the executable that is that file. So basically what you have to do is install CMake, and you put the path here to the CMake, and then allows you to run CMake from the terminal. And when you run CMake, all that is doing is figuring out the code you have here on this file, and then it's gonna build a giant command. Giant depends on the size, but obviously this is gonna be giant because Blender has a lot of code. But it's gonna build a command that runs another program, which I think is gonna be make. That is going to compile the C++ file with whatever compiler you specify here and whatever type of build you want. And basically the main reason I think CMake exists is because it gets very complicated to build for different operation systems, so different platforms. So the main one is Make, I think, that it was created first, and then they built CMake in order to be able to make it easier for compiling for multiple different platforms. So basically, I think that the batch file there is going to be running CMake at some point. So all that this is doing here, I'm looking at the debug because this is the one that I'm running. So just setting the build type to debug. And here, assume that it's calling the file and checking for the errors. And this is a label. So this, I'm pretty sure that C and C++ also have this because assembly works this way. So when you put this go through, I think it's slightly different than the syntax, but it's pretty much the same thing on a C++ and C file. It's basically setting a label which comes from assembly, which is gonna make the code jump to that spot. So yeah, and that's how loops work as well. It's probably gonna find third-party dependencies. So setting the variables on the CMake X. And also setting the variables for Python, I think. So lib Windows Windows 64 Python 310. I only have 311 here. That's all. This one. So they use their own Python thing. Python 311 binary Python X. Oh, so it's setting the Python environment variable to be this Python executable here. I think the reason why they do it like this is because of versioning, so it makes it easier probably. Because if you have another version on your system of Python, you would break things and then it would make more complicated. So they just put the Python version on the source code, the executable, and then this is setting the Python variable to be equal to this executable. So it's probably overriding the environment variable on the terminal, so that when their build system runs Python, it runs from the executable that they have here instead of the one that you usually run, which is the global environment that you have when you install Python on your computer, which is just going to set the environment variable that I just showed there to whatever path your executable of Python exists on the computer. So basically that's all that is doing, I think. It's both for Python and CMake. Weird that for Simic it doesn't have anything. It just gets based on the executable there, but because the thing is there isn't a Simic here. So I don't know. Maybe I'm gonna put this on ChatGPT to see if it says anything interesting. Because I think what is gonna happen is just that for the CMake, it's just gonna look for the one that you have on the global on your system, and that's why it doesn't specify there. Because since the batch file is running on the terminal environment, as far as I understand, the CMake executable is gonna be the one that you have on your environment variables path. So it's just basically setting all the variables there. Uh, in the context of the program, setting the environment variables that your CMake executable already has, but I'm not really sure if that's what's going on. Yeah, so that's what I was thinking about. I thought that was setting the variables for the CMake, but it's just setting the CMake variable in the execution of the batch there to be the path to the executable. So let me yeah, but I'm pretty sure that it doesn't have anything there on the other path. The build files. It doesn't, it just commands stuff. Yeah, so all that is happening is just setting the Python in the CMake path here. Python 310, but if that does not exist, also check the 311, 312. Maybe this was generated after a build, though. So maybe they are building the files. It's not like I said that I thought. Because I'm not really sure if this existed. This is the first time I'm looking at it, obviously, so I don't know. So it might be, this files here might be generated after you run the build for the first time, when you put everything here. So maybe they're taking the Python version and having on your system, and then they're creating these folders here based on that. It might be what's going on. Instead of what I said, which is they're using this Python version that they already put on the source code, and then setting on your thing. So I think it's more likely that he's generating this first time you run, probably. It's kind of confusing. So maybe you should ask ChatGPT as well. The easiest ratio to see. I'm gonna do that now. I'm gonna open the the GitHub with the Blender source code. I'm gonna go to the path there, just say. So it's on build files, Windows. Actually, it's on the other file. It's on lib Windows 64. So I think it doesn't have anything because when I click here, it doesn't go anywhere. So I think probably what is happening is the other thing. So they're using the Python version on your system, and then they're putting the Python executable on that file, on this path here, the first time you build. So it's basically caching the Python version. So the next time you run, so at the first time you run, it's gonna use the one that it has on your system, and then it's probably gonna put the file there. And then the next time it runs, it checks for the one that you have on the Blender, and it's gonna use that one. So I think it's just caching the Python executable there. So next thing, I want to avoid spending too much time on each thing. And the thing that I'm gonna do, so maybe I'll run from here. I already did this a little bit to see, like I created a simple line there to see how it works and kind of learn the commands from the GUI. So what I'm gonna do, which I learned from the previous time on Godot, is just look for the labels on the interface on the GUI, and then search for the labels on the source code and put the breakpoints there. And I'm gonna try to go very fast over the source code so that I don't spend too much time on stuff that doesn't matter to me. And then I can reverse engineer from that point. So basically, yeah, here is a little bit annoying. So if you don't, you have to click and hold to select this. And if you don't have this tweak here, it's not gonna allow you to move the objects. And as far as I remember, in order to add the Bezier curve, you just click here and then add curve, then Bezier. And then it generates the curve here. And there are some other commands, but I think the one that I was using is this. So when you click here, just gonna go to the perspective you have there. I think if you want to pen, you hold shift and hold the middle of the mouse and click and drag. And then to zoom is just the wheel. So the annoying thing was adding points. I don't remember really well how that works. But I think you have to select the curve and do some shift something. I forgot how it was. Z. I think tab. No, tab goes to so maybe I have to click here. Yeah, so is this so you have to go on edited mode there. And then it allows you to change the shape of the thing. But it is kind of annoying to get it there. And then you can put you can press different. So if you press A selects, I think E allows you to move. Yeah. So it's A and E. I think A allows you to. No, I think R allows you to rotate. Yeah, so if you press R, then you move the mouse, allows you to rotate. And then there was, I think it's G. So if you select the thing and you put, no, it's G or something. Basically trying to remember how to create another control point. I think it's Z. No, it's just R, not E. Maybe it's G. G, no. This part's kind of annoying, but I think that the reason why they did it like this is because there's so many things you can do. That's kind of hard to think about. Yeah, obviously I can look that up later, but the main thing that I'm interested on is that in order to make the shape of the curve, you go here, I think. I think it's physics. No, data. Yeah. So data has basically the geometry, it's going to be the shape. And then you go, there's a couple of different ways, I think, but one of them is go to depth. So geometry, I think extrude is one way. Oh, no. So I think it's depth somewhere. Yeah, here. So bevel and depth allows you to create the shape. And there's another thing you can do that removes moves the curve here. But I think maybe it's on the resolution. I don't remember really well. Yeah, so it's probably resolution. So as you increase the resolution, yeah, but I do think there is another thing that I forgot here. Obviously, for this stuff, I'm just gonna look at the tutorials again. But the main thing that I'm interested on is this part here. So I'm gonna write down the names there. I'm gonna try to go over the other parts of the build system fast, and then search for this. Already did for this one, I remember, but I didn't put the breakpoints. So I'm gonna search for these keywords and I'm gonna put the breakpoints. The thing is, it has to be more specific, the better, I think. Probably geometry is gonna be bad. Bevel might be better. Obviously that. So I think a good one would be starts and ends mapping, because it's very specific. Path animation maybe. So they're all probably gonna be. So the way that I think it works, which is a similar way that Godot works, is that there's gonna be a class that creates this whole component here, and the whole component is gonna be divided into the two different classes. One's gonna be probably something related to obviously it's gonna be related to the file system, this up here, and this other one's gonna be related to the state of the object that you're manipulating. And the main thing you add there is the object. In this case would be the curve. And then the curve uses other objects, which are probably other classes, which are these items that it shows here on the side. So I think these are properties of a data object that is going to be part of the curve object that is going to allow me to change the information here. And that's how it works probably. So taper, radius. The problem is that the things that are directly related there. Well, I'm gonna see. So obviously, the problem with ads, that's gonna be very hard to. There's probably a bunch of stuff, so I'm not gonna be able to find. So maybe edit mode as well. I think I'm gonna focus on this. So I'm gonna go back and forth probably. I'm gonna focus on first like the most basic functionality. So the main thing I'm trying to do is just the curve. And the problem is the hotkeys as well. So I have to figure out how to find the hotkeys. In Godot, they have a macro for that, and then they put an enum that has control, and then they do a bitwise operation they do the OR operation to merge two different controls. So if you want a shortcut to have control A, for example, you do an enum that is a control, then you bitwise OR to the enum that has A, that makes control A. So I could look for some stuff like this, but I think I'm just gonna try based on the source code there to see if I can find anything. And once I find one pattern, then obviously it becomes easier to find all the other ones because it's gonna be the same. How to find the shortcuts? I'm gonna have to go back and forth between the source code and the tutorials to remember what each thing does, and then write stuff down. But today I'm just gonna see if I can clarify as much as possible, like in the beginning, to kind of map out in my mind the flow of things. And then once I clarify that, then I go back to the tutorials, then I'm gonna write stuff down, like the specifics of the commands, and I'm probably gonna watch a bunch of tutorials anyway to see how people usually manipulate the stuff to create geometry. Because I think that's this is kind of inevitable. I'm gonna have to do this at some point because it makes a lot more sense than trying to build this stuff from scratch. So the way I'm envisioning in my mind is that it's probably gonna be a system, which is gonna be a loop. Then I'm gonna create a funnel from a Blender to Godot, and I'm gonna have to create a pipeline of like basically a systematic way to translate stuff from Blender to Godot, so that way I can do any shape that I want and change the Godot source code so I can have more stuff to work with. Let me go back to this. So find dependencies if it is one of the convenience targets similar being stats in compiler detection. I think I'm gonna skip these ones because probably like this is probably if you pass variable in the command line, it's gonna call these other things. So the tag architecture is probably gonna be the script that looks for the standard paths on the Windows system to find the compilers and stuff like that, I think. So just figuring out the architecture. I think it's of the OS. Actually, it's kind of both because the hardware is the thing that determines the endianness, I think. So I'm not 100% sure about the details, but I think it's going to be both. It's like both the hardware, the way that they structure the hardware is going to determine how the memory is packed, let's say, is organized, and then the OS as well, because the OS is the thing that manages the memory. So just setting the environment variable based on the whatever architecture. And the thing is, how does it find this? This is sats on the other. I think that this is probably coming from the terminal. So the question is, how do I test? I'm not. This doesn't need to be perfect. The way that I'm asking there. So it's executing the bat file is executing the command line process. So I'm just checking to see uh, whether or not this command works. But it's not showing. I think like ChatGPT is recommending to create a file and then execute the file. Not sure if it's worth to do that. Because before there, it doesn't look like he has anything. It doesn't set this variable, I think, before. The build arc environment variable specifies the target, so I think it is a default variable from Windows. The valid target platforms are AMD64 and x86. This environment variable may be set to a value that is different from the platform on which you are building. So it's probably already like an environment variable that comes with the command line based on the operating system you're using. So it's not Blender that sets the variable. So it's basically just setting the environment variable on their batch to be based the same one that reflects the operating system. I think these other variables are going to be the same, set by the Windows. So here, I think this script is also used on the. So there's an extension that you can do. You can use to set up the debugger on VS Code, which I think is CMake tools. You don't have to use this extension, but usually people recommend. And on some stream some time ago, I went over the source code of this in order to study and understand how the VS Code debugger works. There's a lot of stuff on the documentation from VS Code that they explain as well how it works. But basically, the way that the extension works is just at some point they're going to use the same thing that they're probably using here, which is some code that is going to look for specific paths on the system to find the MS build executable. So it's basically the same thing that they're doing, and then they set up the toolkits that they say. It's just all the tools that are necessary for the whole compilation process, just the preprocessing parts and preprocessor, then creating the objects and linking them, basically. So the linker is a different program than the one that compiles, and I think that there might be other tools, but I don't remember really well. But basically, this tool is gonna look for the paths on the system, is gonna put them all together, and then it's gonna cache that configuration so that when you press the buttons here, it's gonna at some point use the VS Code extension API to call the debug adapter that VS Code uses to put the breakpoints and to go over the code with the debugger. So I think it's the same logic that they are doing here. Like similar logic probably. So this was probably set in the beginning there. I remember seeing this, but I don't know if it was set or not. I think I'm not gonna spend too much time with this stuff, to be honest. Because it's not that interesting, and I'm more concerned with the other stuff. So I'm just gonna have a general idea of how it works. So here, I assume that's an environment variable. Maybe it is. The thing is that the path is different. So maybe it's an environment variable that they set for this specific path here. Yeah, so it is. So it's calling these scripts here. So that environment variable is just probably specifying the path here, the same way that they do on the path for the roots of the Blender. And this is I think it's the exact same executable that the extension uses. Like, obviously it's not the same because here is the command, but the name is the same, I think. The attack MSVC. I remember this name specifically, VSWare, I think, on the CMake tools extension code. And based on the way that Godot works as well, I think that there's probably how all applications are going to work. There are standard paths that Windows probably on their documentation specifies you to put the stuff on the application. So there's a path usually for caching, so cache files and stuff like that. Just probably going to be on the app data user. So I think it's C. Let me just remember. Based on the Godot ones, I think that all the applications are going to use this probably. So it's C users, then the username you have, and then it's going to be on app data. Yeah, so basically C users, your username, app data. And I think that the local is for the cache files you have, and the roaming is for the other types of files. So there's probably standards you have, and they probably have the same standards for these executables of the stuff you're gonna do with C++. Because basically the way that C++ works on Windows is that you download some executables and these programs that are compiled by them. I think I'm not 100% sure, but it's probably Microsoft that developed. I think it's not open source, MSVC. So when you download the executable, it's probably going to put on a standard path. If I remember correctly, I used Chocolate or Chocolate, however you say that, which is a package manager. So it's just a program that is going to do some HTTP, probably HTTPS requests through the internet, and it's going to download the program and put on a specific path on your computer. And based on that, all the applications are going to be, are going to probably use the same paths to find this stuff. So here, that's probably what they're doing. They're just using this VSWare, which is another executable, that is going to find where the installation of the MSVC compiler is on your computer. And then they're probably going to use that to build the commands at the end that is going to compile everything. But I do remember on the Blender documentation that they talk about CMake, and I think that probably what's happening is that, yeah, they say, I think if I remember correctly on the documentation, that when you run the batch system, the batch executable here that they have, the make batch executable, the main one, it's just an easier way to set up the CMake command to compile everything. So I think either way you're using CMake to build probably. The thing that I'm trying to do, so someone's asking what I'm gonna do when I fully understand the code. I'm not even trying to understand the full code. I'm just trying to understand the parts that are specific to the Bezier curve. So what I'm trying to do, I'm developing something like a very simple, I'm not sure if application is the right word, but it's basically something I did on the browser. I'm trying to transfer to Godot, which is a game engine in C++. And in order to do that, I need to create curves in 3D. But the problem is that Godot doesn't have that. Godot has a 3D, has a tube geometry, trail tube geometry, but it doesn't allow you to. You can find a way that programmatically to put the size, but it doesn't allow you to put curves. And what I want to do is use curves. So I'm basically trying to draw these edges of this graph here on Godot. And in order to do that, I need to learn how to do the Bezier curves on 3D, and that's what I'm trying to do now. And if I remember correctly, I put here. So if you put curved, they become curved here. So that's basically what I'm trying to achieve. And I've seen that Blender has this, and also Blender is very good. I think like everyone uses for this kind of stuff, like modeling stuff. So I think probably in the future I'm gonna need for other stuff that I wanna do. So since I'm gonna have to figure this out now, I think it's a good idea to just put the work to try to understand how everything works, and then figure out a way to like create a system where I can transfer stuff from Blender to Godot. But obviously, it's gonna depend on how much time everything takes, because I think that's gonna be very complicated because Blender is very old and there's a bunch of code. So. But yeah, it's probably gonna pay off because I'm gonna probably end up using both Blender and Godot. So even if if I'm not able to transfer, it's gonna help a lot to use the editor here if I understand how the code works. So it's gonna make everything easier. So I think it just makes sense to put the time to understand. Not ChatGPT. It's just just create a system like because once I understand how usually that's how everything is gonna work on all the applications. Like it's just one pattern repeated in different ways. So like you use the same standard, let's say, like the same blocks of code, and then you just put, it's kind of like classes on C++. Usually you create one class and then you have variations of that same template of the class to create different things. So once I understand the general structure of how Blender creates the objects, I can transfer the information that they use, the algorithms that they use to build the vertices, and the functionality to build the models into functions. And then from those functions, I can put those functions on Godot. Because all that is happening is that you're basically building vertices, and then from the vertices, you create triangles, and then you send this data to a buffer. And the buffer is gonna, the framework you're using, the rendering framework, is gonna use that buffer, the information on the buffer, to throw in a shader pipeline to build to draw stuff. So that's basically how it works. So as long as you understand how the vertices are being built and I'm able to transfer the functionality, then I will be able to do any shape, I think. Because Godot already has a system for like allowing you to build any geometry you want. Oh, the other thing that I realized and that I thought it wouldn't be possible, like on Godot's documentation, they say that the custom geometry is not very optimal and is low performance because you have to rebuild the geometry each time. But after thinking about it, I think that's not going to be the case because you can put functionality on the C++ code that allows you to only change the geometry based on events. So only if the geometry has to be dynamic, you send an event that if you change the, so for example, I can change if I change the position of the nodes, if on the function that I change the position of the nodes, I put an event that tells the edge to change, then once that happens, I can change the geometry of the edge. I don't need to constantly change the geometry of the edge each time. So, and I think that the reason why they say you need to do that on Godot's documentation is because usually people are gonna do from GDScript. So there isn't a way, I think, to um, but maybe even in GDScript it's possible to do that. So you don't need to rebuild the geometry each time. You can do it only if something changes. And I think for dynamic geometries, you kind of have to do that. So in Godot, pretty much they have standard geometries, which are geometries that they build the vertices for you. They have the algorithms that build the vertices, that build the shapes, which is like sphere, cylinder, all this stuff. And then they have an array mesh and immediate mesh, which are classes that allow you to build custom geometry. And it basically exposes for you like the function that you can use to build the vertices yourself. And usually that's gonna be used if you wanna build a dynamic geometry because it makes like the other shapes are useful if you just build the geometry once because it's more effective to do it this way. So you just build the sphere once, and then if you want to translate the sphere, you just change the position of the sphere instead of changing the actual geometry. But some shapes you can't really do that, and I think that the curve is like a situation like this. It's kind of like water as well. There's nothing you can do. You have to change the shape. So every time you need to change the shape, it's gonna be less optimal, and you need like to customize the function for the function that builds the vertices. So I think I'm gonna pass this. Yeah. So I'm not gonna try to understand the nuances here, but it's basically using the VSWare executable to find the MSVC build, and then it's probably gonna set an environment variable on this that uses that compiler. I'm not sure what you mean by this. Follow the white rabbit. So let me go to the other one. Oh, matrix reference. Yeah. It's been a long time since I haven't watched The Matrix. It's a classic movie, obviously. Yo, man, thank you. Thank you for the message. So this is when you pass the updates thing there. So they on the documentation they recommend you to do this command first. And check libraries. So there is basically changing the path here. So lib Windows. Yes, it's gonna be the other path there that the executables are at. So obviously it's gonna depend. So this path is the one that is sets there before, and whatever folder you use here is gonna depend on the path. So it's probably different files specific for each operational or each architecture. And I think that these are third library dependencies probably. So yeah, whatever. So they probably use this environment variable at some point. So git here. Oh, so this is the reason probably why you need to have git. So I tried the first time that I tried to download everything and run, I did it. I tried to do it straight from CMake, but it didn't work because it complained that it didn't have the git. So I think the reason why you need to have git and you need to clone the repository first. So you need to clone it from git is because they're probably going to use git to download the dependencies, and probably you need to have like a history or branches maybe or something like that. So this one, yeah, not really sure. Because there isn't any file here that follows that pattern, I think. I guess I can search for here. I do remember, I think the last time that I looked into this, I stopped here as well. And I didn't find anything by searching for this pattern. So obviously here is going to be the thing that sets here. So it's going to be Windows and whatever. But I'm not really sure. Oh, so it's probably from the Blender there. So it should be on the roots there. Oh, but it doesn't have any files here. Hmm. Hmm. Maybe it's this stuff. Maybe it's because it searches inside of the file. It's kind of weird because like the command here makes me think that like it's gonna run this file like from the roots of the project. I think the Blender DSM should be the root there based on the other stuff. And then it's gonna run the other file, but it doesn't have any submodule file there. So I think what is happening is probably running some of these Git files here. So it's probably the Git modules file there. And it's gonna look for the dependencies inside of the Git modules file, I think. So it's using Git to resolve the dependencies, I think. Not really sure. So it's setting Blender there to be the dependencies thing. And this path, I remember it wasn't on the thing there. I don't remember which one. I think it was the lib one. So it was this path here, but it doesn't have anything. No, I think it was dependent on the thing. So it should be one of these, but I think it should be probably that file, the first file that I saw there, that is running there. But I don't understand why. But I'm not gonna spend too much time on this, like trying to clarify the nuances, because I think it doesn't matter that much, and I don't wanna get stuck on this kind of stuff. So I'm just gonna go over, because I do understand, like on a surface level, what is going on. Actually, like obviously I don't understand for sure because I'm assuming things, but based on the way that I'm looking at it now, is gonna use this git modules file to find the dependencies, the submodules. So it's basically gonna it's gonna make a call to a URL that it has here on the file, and then based on this URL, it's gonna download the other dependencies that the project has. It's solving the third party dependencies using the Git. So I think that's what's happening. Yeah, so basically the URL that it has there is this one here, and this one has these files here. So I'm pretty sure that this is what's going on. So it's using Git to do curl requests. Curl is just the program that you can execute on the terminal to uh, send information back and forth between your computer and websites. I'm gonna go get something to get more tea. So I'm just looking at the file here. Yeah, I think it's pretty much it. So it doesn't have anything here. So like it's just based on the architecture, and the for each architecture they have different URLs here. And then it's just gonna probably build a command to get this stuff here, I think. But it is kind of weird. So I assume Git is gonna be, yeah, Git's gonna be the path to the Git executable on your computer. So it's using the Git executable. So one thing that I can try is just run this executable here. Run the command, like figure out the command, this ChatGPT, figure out the command, run the command from the command line, see what happens. But then I have to figure out this path here. Like, the thing is that this seems to be like the file, so I'm not really sure. Like maybe it's worth to ask ChatGPT there. Let's see. I'm just gonna ask like this. Let's see if I find. I don't think it makes sense to be stuff related to Python yet because I didn't see anything related to that. But maybe it is. So the question is, so like the other thing is I can assume that this isn't the case there. So the first time maybe this doesn't run because it don't have git sat there maybe. Or maybe not. I think it's supposed to run. Because the other stuff is just error messages. So if it doesn't exist, if .git doesn't exist, it also might be because it's not showing the files here. I'm pretty sure. Yeah, so maybe from VS Code, I think it doesn't show the files. So I'm gonna look into the builds there. It doesn't have anything here. It does have a Git file that it doesn't show here. Just trying to see if I can find the file. So two directories up, which is the roots, then dot git modules, the git modules, lib windows. Hmm. So the git file that doesn't show on the IDE, which is on the path, that on the lib path from the roots, it has a git key value pair called git dir, and the path is to the git file on the root of the project that is on modules on git modules lib. Yeah, so from the git file at the root of the project, it's going to be on modules lib and then Windows 64. But it doesn't have anything here, I think. It doesn't have anything with the name there that uses there. It has an update sample file on the hooks here, but it's whatever. So I'm not really sure what this is about here. I think it is what I said there. So just using git should download, but I don't understand this path here. Let me check out. So it's running git executable from the, I think Blender there. Maybe this one I can figure out here. So this one is gonna be this, but so I guess I can see. I'm gonna see if this means anything. The full path to the directory where the batch script itself is located. So this path should be the Blender one. So I think that the Blender there is gonna be the path to the Blender directory there. Makes sense because the other paths here. So it's running git from that path. So I stop here. And passing C, the Blender directory, config local submodule. And what is the build versus lib there? I think that this path is going to be the one there, this lib path here. It's weird that it doesn't have though. Like, there's no submodule here. That's the thing that it doesn't make sense. So like it makes me think that this is accessing a file. Because sometimes that's how like some programs resolve paths through the dots. So access photos hierarchy through the dot. Leave dates. It might be like internally on the Git stuff. Like on the Git folder there. This folder. I need to remember how this stuff works. So one thing that I can ask there is the commands. This is the last thing that I'm gonna ask this, and then I'm gonna continue there, so I don't spend too much time with this stuff. So it's setting a configuration key. So I don't think it's installing that. I do think that the intuition that I have there is correct. That it's gonna use Git to download stuff. But I think here is probably just setting environment variables for Git. Or maybe this one updates. It's basically some Git stuff. I think that the intuition that I have is correct. Just gonna use Git to download the dependencies based on the URL that it has there. Yeah, so that's basically what this file does. Let's skip this one. This is if you're building with Ninja. So I think that's pretty much all that it's doing here. Yeah, so I looked into what happens when you put the updates. So let me go over again if you don't have anything. I don't figure out the other environment variables are used in the command. I have to, yeah. I don't think it matters that much. Sure. No, but it's basically because it probably changed the path there that I was looking at. So it's gonna be based on the one of the subfolders on the roots of the project. Gonna be targets, build architecture, the version. So the file there that it uses might be on one of these other files. So the thing that is weird to me is that I looked into the like all this stuff and I didn't see anything like they call CMake or something like that. And then there with blah blah blah. Oh, so it's probably here. I missed this one, I think. Hmm. Oh, so it's using this one. Yeah. So if you specify Ninja, then it's gonna use this one. That makes more sense. So this is gonna be the bash scripts that are used to actually build. So I think it's pretty simple. It just uses the VSWare to find where MSVC is installed. Then it's gonna use Git to download the dependencies. Sure. Yeah, and then the final thing is probably gonna be to run this stuff. So build files, Windows, configure MS builds, and then the other one is builds, MS build. Yeah, so it's building the CMake command. Yeah. So the reason why I think you need Git is because of the dependencies there. So it's using Git to install. But maybe there's a way to change, but I think it doesn't matter that much. But yeah, if you wanted to change, I think what you can do is just download manually or set up on CMake the commands. Like you can change the CMake test file to install this stuff for you instead of using Git, I think. And yeah, it's pretty much, it's like they say on the documentation, it's just to make it easier here, I think. But if you use this batch file, then you need to have Git to install the dependencies. So it finds MSVC and then it's going to build the CMake commands. Sure. This one is the generator on CMake. So yeah, it puts other arguments here probably if you pass other stuff. And then when you pass here, you select what kind of generator you want to use. So I think by default, if you don't put anything, it's gonna, it depends on the operation system, I think. So if you're running on Linux, I think the default is Ninja. I don't remember. No, I think if the default is Unix makefiles. Actually, I'm not 100% sure. But I do know that you can use Unix makefiles as a generator here if you pass Unix makefiles strings. Then CMake, what CMake is going to do is going to build another, on the build folder, the final build folder, you specify your CMake. It's going to put a makefile on that folder. And then what you do is you run that makefile on the folder, and then that makefile is the one that generates the executable. But if you're using MSVC, then you just run another CMake command after you run the first one, and then the other one uses MSVC to build. So you need to do two different commands. The first one sets up CMake, and then the second one uses the compiler to compile the application. And it's basically these commands here. So that's usually how I do it. So this one is gonna set up CMake on the build folder from the root of your project. And this one is the one that uses whatever build you have to build. And you can change the variables here at the end that you pass. Here is basically the path where the build is at, which is the dots. In that case, but yeah. So, alright. So that's basically what it's doing here. It's just building the CMake command, I think. So I'll build the arguments here and then I'm gonna call CMake. So maybe I should spend some time looking at the CMake file now. It's gonna run probably the main CMake list there from the root. Just acting. There isn't. Here, there isn't anything. This Blender SLN file. I must configure one. No builds. CMake arguments. So it's just, I think it's running this stuff here. Yeah, so this is the command probably. So here just echo is the output. Yeah, it's kind of like some statements. So the build directory is going to be the one that, yeah, so this directory here is the one that builds that, which is the one above the, where you have the start code installed. It's basically the path, this stuff here. Usually the way that I build the path there, the way that I showed in the drawing is going to build, this path here would be inside of the source path and on the build folder. I think this might be the reason why it has here, because I tried, the first time that I tried, it just directly with CMake, but then it didn't work. So I think that this path that they put here, which is the build path, is going to be one boot above the source code, and then it's just gonna put the CMake files here. So just running the CMake list file from you and building the command from you using Git to figure out. Yeah, depends. So now I'm gonna spend some time looking into this. So this is the main file that they're gonna use on the CMake list. And usually the way that people do CMake lists is that they put, so the CMake allows you to put logic inside of it that specifies that allows you to put other CMake lists as part of the build. And also allows you to do fetch declare, I think, which is just basically, I think under the hood it probably uses curl or something like that to do HTTP or HTTPS requests to download third-party libraries as well. But the way that I usually do it on the other projects is just by adding subdirectory, which means that you're gonna add other CMake lists to the build. So they probably have CMake lists here on the other parts, the other ones, and then the main one just uses these other ones to figure everything out probably. So I'm gonna try to go fast so I can start. The next thing that I'm gonna do, so first I'm gonna spend some time on this one. Next thing I'm gonna do is just use these patterns here to put the breakpoints on the source code. Then I'm gonna start the debugger and go over a little bit to see if I can figure out the functionality there. So this is just defining the build type. So release is obviously for release debug. The main difference I think is the symbols. So when you build for debug, it puts additional symbols on the final executable, which makes the executable bigger, but then it allows the debugger to attach breakpoints to it. So if you don't build for the debug version, the final executable is not going to have symbols, and then the debugger is not going to be able to put the breakpoints. And also if you're using GDB from the command line, it's going to be more annoying to see everything because it's just going to be memory addresses. I think it's not going to have names. Settings CMake policies. So this one includes the other CMake file. So I remember using this on another project, and I basically use this to include other variables that I had on another file, but here they might do it for something else. So it's basically including macros. So macros is like kind of like functions. I think it's probably similar to C++ actually. Maybe not C++. Yeah, I think it's probably C++. So just paste in the code there. So usually probably people do this so that the code on the main CMake file doesn't get too bloated. So it's just declaring variables probably that the build's gonna use. This is looping over this path here, I think. So it's basically, the way that I think about it is like a function, but I'm not 100% sure about this stuff, so I might be wrong, but that's how I'm thinking about it now. It's like basically like a function that is going to replace whenever you call the macro. So the name of the macro is going to be probably the first thing that it is here. So whenever you have this key on the other one, or maybe it's used on some other files, it's going to do the command here, or run the command with these arguments, I think. So you pass the one directory, the other one, and then it's going to create a list on this variable here, I think. Let me see if there's other. Oh, so here's this only one. I think it's just declaring macros, and then it's going to use these macros on the other files, obviously. I'm going to get some tea. Be right back. Like I said, I'm not going to spend too much time with this. I'm just going to try to go faster so I don't get caught up on a bunch of stuff that doesn't matter to me now. So it's basically declaring a bunch of macros. I'm just going to continue from the main thing here. So I'll be right back. Yeah, there we go. So it is like I was saying. So the first name here is the name of the function, let's say. So the macros are just creating functions, and then it's gonna run whatever code you put here. So this just sets the release flag. The name of the project is usually like once you set the name of the project using this stuff here, you can use it from the environment variable. So usually the way that people do it, it might be the way that I used to do it, and that I've seen on other tutorials, is that you use the environment variable that is the name of the project to create the final executable, so that they have the same name. So it might be the way that they are doing here, and yeah. So basically, so it could be the same because the final name is gonna be Blender. So they're gonna later on use this as an environment variable to build the executable. And in order to build executables, use add target on CMake. That just makes it so that you can. The way that it's gonna work is like I said in the beginning. Like you're just building another command that is gonna probably run make. I think, or I think it depends on the compiler you use. So it builds the command to use the compiler you have. That's gonna create the object files, which are the source files for the program, and it's gonna link them. So create objects from the sources, and then link the object files, and then create the final executable based on that. And if you want to create more than one executable on CMake, all you have to do is put more than one add target. So whatever target you put is going to be the executable. If you use add library, it's going to allow you to put other libraries. So if you have .dol, for example, is dynamic linked library, and there's other names I think for static libraries like other extensions. So basically, when you use add libraries, it allows you to compile the other object files and puts on that file, which would be like a DOL or the other extension. And then it allows you to link that library with the executable as well. So it's basically setting some variables here. Display some errors, but files to make have features. So it's checking to see some symbols. So I guess this is gonna depend on the compiler you're using, the type of build. So they're checking to see if the compiler you're using has some information or some of these features. I'm just gonna move on to the other stuff. There's a lot of code here. So I'm just gonna go faster. Because this stuff doesn't matter that much. It's basically just building a bunch of environment variables and then setting flags based on the variables to see what kind of things the build is gonna have. So I'm gonna go faster. Maybe looking for add targets already or add library, stuff like that. Compiler, blah blah blah. These flag variables, there's a guy I talk about him all the time. His videos are very good. It's called Jason Turner, and I think it's C++ Weekly with Jason Turner or something like that. His YouTube channel, and he talks about the compiler flags all the time. So these flags here, they change the amount of information that the compiler shows, and I think they change some other stuff. And in some situations, it's very important in good to put the flags here because they help a lot on the debugging. So yeah, that's probably what they're doing here. I'm just gonna look for a target and then I'm gonna start looking into the source code. Yes, let me just look because there's shit ton of code here. It might be on some other CMake files that they use here, so. This add subdirectory here, what it does is just looks for the CMake file on the path you put here, and then it's just gonna run the CMake file for the path, the CMake list tags file that exists on that path. But these paths here might be some like relative paths. Or it's probably the paths from the root, so the source, the intern. So just running the CMake list files that it has here. Oh, so this one is not very big. So find package is another thing that is used all the time. And I think what it does is just looks like this is for third-party dependencies. And it's kind of annoying to use the find package. Usually I try to avoid because I think it involves making like requests on the internet and also dealing with standard paths on the operational system. So on the builds that I did for my stuff, my projects, I didn't use much. But sometimes like for OpenGL, I had to use, I think. So you put the name of the library here, and then required is so that it breaks if you don't have the third party dependency. And here is adding another subdirectory, which is probably gonna be the code, like more code. So it's just setting the environment variable, this environment variable to contain all. This DNA thing I've watched in some videos, some explanations. So I think that they make analogous to the way that the body works, but I'm not 100% sure about this, but yeah. So like the DNA is the structure of the thing, and then the RNA is the modification of the thing. So DNA is like the core classes, let's say, and then the RNA is like the behavior of those classes. And it's something related to the way that genes work that I don't understand very well, but I think that's the logic that they use here. So these files are from the source, and the source I think is the main. So the source is the main folder that contains the core of the application, and the creator is the entry point there. The function, the class or the file that I have here opened is the first entry points. Oh, the other thing that I forgot to mention is that usually it's a good idea in the beginning on the launch.json to put this stop at entry equals to true, because what that's gonna make is that it's gonna make the debugger stop in the first function that gets executed. So if you don't know what the file is, that is the entry point of the application, you just put true here and then it's going to stop as soon as it starts the program. The debugger is going to put the breakpoint there. So that's basically what I did, and it stops here. So this is the main entry point for Blender. And based on the other tutorials that I've seen, I think that the main files are going to be on this Blender folder here inside of the source. And this DNA is probably the core of the thing. So continue. So it's adding the subdirectory here, and just adding. So this one adds a bunch. So that's probably, it's very similar to the way that Godot uses scones, which is another system. Scones is built on with Python, but it's basically the same logic of CMake. You just use with Python instead of CMake because Python is more powerful. I think that you can do more stuff with Python. But scones works pretty much in the same way, I think, where like you have one, shouldn't say scones, but Godot. You have the main s-construct file, which is the file that is responsible for running the script, which is on the root. And then inside of the file, we have s-conscript, I think, which is the name of the function that scones uses to add other files. So the analogy would be on CMake, the add subdirectory is the same that of s-conscript on scones. So s-conscript is equal to add subdirectory, but for scones. And the way that they do it is pretty much the same. So you put these files on subfolders, and it allows you to compartmentalize the build process because I think it makes it easier to manage files. So instead of putting all the code on one file, you just put other CMake this file on the subdirectory, and then each one is gonna be responsible for creating the compilation process for that folder. That's basically what they are doing here. But the problem with this is that there's like a lot of code, so it's kind of hard to understand. Because I'm not really sure if it's worth to spend a bunch of time here, but what I wanted to see is if they are building this as a library or yeah. So here's one example, I think. So yeah, they're not using add target, they're using add executable. Interesting. Yeah, but I think like, and this, I think this stuff I'm not gonna spend too much time, but probably what they're doing is building like on some of the files they're building libraries and other ones are building targets, and then all this other stuff is gonna be combined at the end to build the final executable. So if you look at the source folder there, yeah, here there's another like several different other library other files. So this .lib I think is a static library. Yeah, so .lib is static, and .dll is dynamic linked library. So yeah, probably at some point on the CMake code, we're gonna have the add library command that is gonna create this dynamic linked library, and some other libraries to create this .b and the .lib, which are static linked library. And the difference between dynamic and static is that dynamic allows you to put the code at runtime, as far as I understand now. So it's like more composed than static. Static's like you're making the code part of a building, and dynamic is like you're making the code as a transportation thing. So the code is on the car, not on the building itself, and the data is being passed through the resources. So like dynamic is you're moving the code with cars that are outside of the main thing, and static you're putting another floor on the building, let's say. So it's a part of the main project. So dynamic allows you to have more flexibility, but then it increases security risks. And also makes it faster compilation times because you can, it decreases the amount of stuff you have to compile each time. So one thing that I'm gonna do is look for the add library on the main thing there. Just see, I can look for the path there of the files here, but it doesn't matter that much. So it's basically adding a bunch of subdirectories, blah blah blah. And so I think here I couldn't see any. So the way that they're probably gonna do it is gonna be on the other CMake files, but they're probably using the adds executable instead of add target, which is basically the same thing, I think. But the thing that might be confusing is the Python files, because there might be at some point they might be combining CMake with Python, but I think it doesn't matter that much for now. We'll look for executable there as well. I do think there is a difference between them, but like, it doesn't matter that much to me now. So there's a bunch here on the intern, extern. Fuck. Didn't want to do that. So I'm gonna look for the last thing I'm gonna do is just look for add executable, then I'm looking for the patterns. I'm gonna look for the patterns there. So they use add executable to build the targets instead of add target. So I'm gonna ask ChatGPT. I'm gonna search for add executable. Add executable to the projects. No. It seems like it's pretty much the same thing. Maybe I confused the two. There isn't add target. But I do remember. Maybe I confused the commands. Yeah, now I'm not sure, but I do remember using add target. So maybe I was just confused and just added executable. But I think it's gonna be pretty much the same. It's just creating the final executable. Well, let's see what I can do. Just look for this. So it's on the source creator that's gonna create the final one. It's probably this one. So in this file here is gonna create the final executable there that you use to run Blender. And this, I think it links this library with the Blender for a private way. This is just with CPU channel. Yeah, whatever. So here it seems to be. So this I remember seeing there on the first file there. I think the one that sets up the macro or some of them that sets up environment variables. And there was one thing there that's checked for this one and sets to on, I think. So I think this probably is gonna be the thing that merges CMake with Python here. So whatever. I don't want to spend too much time. I think I already sing enough. So I'm just gonna start going over the code. I'm gonna look for the patterns there. Then I'm gonna run the debugger. I think if I actually wanted to build on Blender, then it's probably worth to spend more time on the source to understand. But maybe it doesn't matter anyway. I think if I wanted to change the source code, then and maybe at some point I will have to spend more time because then you have to change the CMake files. But I think all you have, like probably the easiest way to do it is just by including another CMake list file. So use add subdirectory, create another folder in one of the directories you want to change the code, and then you add another CMake list to that directory. And if you want to change the code on one of the other subfolders, there's probably going to be a CMake list related to that folder, and then you study from that point, I think. But I do remember that you have to specify on CMake the source files that's gonna compile. And you pass on the add executable or add target, whatever it is. Or the add library, you put the sources, which are the C++ files, and then you can use a macro to loop over based on flag variables. Or wild card thing there. The wild card pattern that allows you to include also all C++ or C files from a directory, for example. That's probably this. So here I'm going to exclude this stuff here. So maybe we should just put CPP or CC files. Just excluding the files that I don't care about. I didn't spend a lot of time, but I think that the way that Blender works is that there's some parts that they allow you to use Python scripts to do stuff, but I don't know yet how the connection is made. Like, how do they integrate Python with C++? So I'm not really sure if it's worth it to exclude the Python files because maybe there's gonna be obviously there is gonna be stuff that is useful, but I just don't know the connection yet. And this, yeah, like I imagine it's not gonna be because the thing I need to find something that is more specific. I'm gonna look for all of them and see if I can find at least one that. I remember the Bezier curve that I found looking into the thing. So that's one. Material CC also looks interesting. That's probably the file that they use to build materials. So, and this is a fundamental pattern in graphics programming. We're gonna have a material and gonna have a geometry, and then you're gonna have another class which is a mesh, which combines the two. The geometry is the shape of the thing, and the material is the style of the thing. So material, like analogy with the browser's material would be CSS, and the geometry would be HTML. So geometry is the structure, and the mesh is JavaScript. So it's combining both. It's obviously not perfect analogy, but it's kind of along those lines. I'm gonna look for another pattern. So probably the best thing to do is the Bezier. I'm pretty sure because I do remember searching for this. I do remember that I found a file there. Yeah, curve. This file here. But I'm gonna put breakpoints on these ones. The same function. So it's a source, Blender kernel, internal curve. I don't think it's worth to put. So one mistake that I did when I was studying Godot was to put a breakpoint on every single function on the editor node, but I regretted doing that because like there's a lot of unnecessary breakpoints, and then like I spent a bunch of time removing them. But the tricky thing here is to figure out where, because ideally I would be, ideally I put breakpoints on the that's like on the functionality that happens after you click the add button, for example, so I can investigate from that point what happens. So maybe if I search for, yeah, but the thing is already start is like the true paths here. So I think it's gonna be on another file because obviously it's gonna be a bunch of classes that are related and send information for from each other to figure out what happens. So this one is probably interesting as well. It's something for. I do remember looking at this macro here. Yeah, this one is interesting. So this is probably the function there that builds the option. Construct a Bezier curve. Interesting. So this one is probably better. Construct a Bezier curve. I think this one is probably this one and the other start and mapping is gonna be easier to find. Yeah, but based on this here, I can already tell like that class is gonna be the one that is responsible for creating the object, and this one is probably gonna create all the objects, and then there's gonna be specifications. So what I want to understand is like how do they? I think that's probably more composition than Gorot, the way that they are doing. So it's not instead of creating one base class and then changing the behavior for based on the derived classes. I think they are doing more from like different classes, composing classes from each other. But I'm not really sure. Well, so I'm not gonna spend too much time on this. I'm gonna look at the other ones. I wanna look into the most specific, and then I'm gonna put breakpoints, step over. And the more times you step over, the easier it becomes to figure out other breakpoints that might be interesting. Because obviously you're gonna look into the relationship between classes. But here is just a variable. Oh, so the other thing that yeah, the problem is the DAP. I'm gonna see if there are two tips there on the DAP functionality. So I'm gonna look for the most specific thing here. Yeah, so it's on these breakpoints that I put here. So this is probably gonna be the function that generates the thing there. It generates the options. So when you click, it adds the thing. So the other thing is here. Length of the DAP added in the local direction. Tooltips are usually easier because it's more descriptive, so it's more unique. I'll put a breakpoint here. Thing is, this functionality is probably not the one that builds, but is just related to the UI. But I think they're gonna be related, probably through these props here. RNA def prop. So the RNA and DNA is probably the main classes. The RNA is the behavior. So it is more composition, I think. So probably they have a bunch of classes that. So like the class that creates the curve is the DNA, for example, and the class that shapes that allows you to put depth to the curve is the RNA. And then they like doing things this way allows you to compose the different classes with each other. So I think that's how it works here. And probably the annoying thing about this, putting breakpoint here is probably that it's gonna run a bunch of times. So I think it's not gonna be very good to put here. But it's still kind of interesting to look at the code here. Basically, the main thing that I'm focused on is figuring out the what exact function from the curve is gonna be the one that builds the vertices, and how do they what equations are involved into doing that? Because the challenging thing is that the way that they do that is more like a static thing that doesn't change. So I have to figure out like because the way that I'm gonna do it, the way that I'm thinking about doing is a function that receives two different points or more, and then based on those points, it builds the curve and puts the shape programmatically. So I have to see how do they do this here. Because it might be the way that they do it because of the decomposition, like different parts of the codes that do different things, and then the overall thing gives the. So like I'm trying to say is that it's probably not only one function that I'm going to be able to look at and get all the vertices. It's going to be like I'm going to have to deconstruct a combination of functions and then put them on only one function because I want to do everything at the same time. And because of that, I'm going to have to understand several different classes probably, which might be annoying. So now I have to remember where did I put the depth here. Here. So I'm gonna put here. This one is the most important, I think. Bevel depth. Radius of the bevel. Be right back. So I think this is probably enough to run the debugger. Interesting. I'm gonna put on this one. This is one of the things that I'm curious about. I'm probably gonna watch videos as well to try to understand this. It's how they connect this plus plus code with Python. Yeah, so I'm gonna close all the stuff here. Close all the files, then run the debugger. Oh, the other thing I have to see is the shortcuts. So what I'm gonna do is I'm gonna try to figure out the classes involved. So I'm probably gonna, not sure if I'm gonna do the flow chart, but maybe. But I'm gonna try to write down all the classes involved to build the curve and put that. Then once I know those classes, I'm going to see, based on those classes, just gonna read the code for the class and see if I can find anything that seems to be related to shortcuts. Then based on that, I can put the breakpoints on the shortcuts. We don't even need to put the breakpoints, just look at the function, and then if it works in the same way or in a similar way that Godot works, it's probably gonna be a function that is passed through a macro, and then I can look at that function and see how does the functionality work to build the shape. That's another thing that I have to figure out because I need to do this programmatically. And I'm not really sure if they have. I think the way that they do it is they have a standard way for the Bezier curve. So like it's a source point and a target, and then one or two control points in the middle. And that's how they built the first one. And then they have probably they allow you to manually put other points based on the thing. So what I'm gonna have to do, I think, is figure out for each, like figure out the function that you use associated with the shortcut to put more of a control point on the Bezier curve, then combine the function with the other ones. So that's basically what I think. Basically what I'm trying to do. Like figure out from the source and the targets how to build the first Bezier curve, then get the functionality for more control points from the shortcut and the functionality for the DAF, and then build the vertices from that point. I'm just gonna press F10 on all of them because I think it's gonna stop on the breakpoint. Goes over. Here's probably just parsing the command line arguments. You pass to the executable. I think this was a mistake that I did on Godot, that I spent too much time on the nuances first. And I'm gonna try now because I think it makes more sense to just go directly for what I want, and then after that, if I want, I spend more time on each function here. So this is the one, first breakpoint. So I guess that the last function there that stopped on the main one is the one that, so it probably skipped some stuff because I pressed F10. So it's F10 step over, which means that you just, if I didn't have the breakpoint, it would just go over this function. So I think that this one is the main entry point for the application to start. And before that was just parsing arguments, setting up the Python stuff. Yeah, so there's a bunch of stuff here, and this gizmo here is a keyword that is on Godot as well when it comes to the rendering server. So, but I'm not really sure what it's about. So I'm just gonna ask ChatGPT. I'm gonna put the whole thing there. Yeah, so let's wait to do transformations, some things. Just looking at the name of the functions first before I continue from the breakpoints there. one thing that I'm gonna ask ChatGPT, what's driver does Blender use? Yeah, they're just probably, I think it's gonna be Vulkan, but you probably have the like a system the same way Godot has to figure out what kind of driver you have. Then depending on which one I have, it uses that. So the default on Godot, if I remember correctly, is going to be OpenGL, and then if you have Vulkan, then it uses Vulkan. And I think if you want to use DirectX, then you have to specify. But I'm not really sure about this. But yeah, I think if you have Vulkan installed, then it uses Vulkan. Because I didn't do any setup on mine, and because I have Vulkan, is using Vulkan, and I didn't specify anything for Godot to use Vulkan. Yeah, whatever. This is another thing that's gonna be might be very difficult, which is figuring out the shaders. Yeah. Because you might have to, but I think hopefully I'm not gonna have to dive into the shaders because like, all that I need is the points, which is the data sent through the buffer. So I don't need to know how they build because obviously I'm gonna be using Godot's system and I have access to the function there. So at least for now, I don't have to know this, I think. So I think this is building the UI stuff for the first time. So primitive is probably going to be related to the mesh. Curve serve primitive. COP type. So this is the namespace that I saw there. It's passing the context. This thing here. This one I'm pretty sure that I've seen there. Yeah, it's the one that I saw on the path. Oh, there's other types here as well that I've seen on some tutorials. That is variations of Bezier curve, but I'm gonna focus on the Bezier, this one first. Then maybe I'll look into the other ones at some point. So I think this is just a compatibility thing. Not really sure though. So it's just switching the name. So yeah, this is probably an old name and then switching to the other one. Yeah. So I think previously they had this name here and then they changed and then they're using this stuff to updates. So this gets the name and you have the context here and then pass this other stuff. This is probably going to be the place that adds the type here to the edit. And this namespace is the thing that has the functionality for displaying whatever is going to show there. Yeah. New primitive matrix. So this is the stuff probably that builds the primitive. I'm going to put a breakpoint on this, I think, because it's probably related to the vertices, I think. But the problem is that it's going to be one of those things where it's going to get called all the time, I think. So I'm going to have to figure out a way to just or set breakpoints on stuff that is just related to the curve or to the moment you add the stuff. Yeah, whatever. I'm gonna continue from the other points there. Not sure, I don't know if I'm gonna put breakpoints there or not. But I'm thinking of starting to understand not that hard. So I have the main context. The main context is the thing that they use to manage whatever is gonna show there. And then you have this RNA and DNAs, like I said before. So that'll be the main classes for the different types, and then the way that they update the types is using the context. So, but obviously I don't know the details yet. I think that's what's going on. So based on the enum and the name that of the type you pass there is gonna the context is gonna figure out what RNA pointer and DNA pointer to use to set the type, I think. So this object is probably the base class for the DNA stuff. Yeah, DNA. Interesting. Raw data. So I do think that is more composition, like I was saying. So on Godot, the way that it works is that they have this base type, which is also an object. And the way that you change the behavior of objects is through inheritance. So it customizes based on the derived classes. But here, I think the way that they are doing is that they have this base type, which is an object, and the way that they customize is through the data, which is a class that is going to probably make the bridge with the other classes, I think. So probably the main things that are used is this object and the context. So the object serves as the bridge. So the context uses the object, and then the object uses the data to manage the whatever shows up there, I think. I don't understand what these layers are though. I do I know that on Godot you have layers as well, but I don't remember exactly I think it's to do the collision. I don't remember what is the point of the layers on Godots. Maybe collision or like figuring out what thing is gonna be displayed on top of each other or something like that. So here is interesting as well that they're using ID. So I wonder if they also use a global object to keep track of everything. Yeah, so whatever. I forgot where I was already. So I'm just gonna press F11. So here. So another context for this thing. Is gonna be probably inside of this other context here. So it's inside of the data of the B context. I don't know which one to click first there. This probably, like it says here, is gonna create the window and probably manage stuff from the window. And this is the data, the main data. As this main, this thing. This shows the Python stuff. So main is a linked list, I think. Blah. So I think it holds information for each thing. Like the main entry points of all the data used on the thing. Raw data. And let me continue on the other point. So just press F11 again. And skip this one. Generic prompts. Okay, alright. I think this, like, it's not that hard to understand. I think this stuff doesn't matter that much to what I'm trying to do. The main thing is finding the functions there to create a. It does matter because I have to understand more like how the flow of the function works. So eventually, what I'm gonna do. I'm not pretty sure if I'm gonna do this today because I've already been here for over 2 hours. So I think probably some other time, probably tomorrow. What I'm gonna do is just I'm going to execute everything until it opens the GUI, and then I'm gonna try to put breakpoints only when I interact with the GUI at certain points. And I think that's probably the best way to break it down and to figure out exactly what's all the functionality that I need. So probably write down the classes and the functions involved to create the vertices, then extract that functionality, puts everything on a function separately, and then see, like, try to deconstruct everything that is specific to the way that they do it so that I can replace with just C++ code so I can translate to the other stuff. It might be very hard because of these nuances here. So far, I think I'm understanding everything. So I wanna see. I wanna. I'm gonna try to go fast over this. I wanna see what function called this one, because here it doesn't look like there is anything interesting. It's just initializing the prompt for the first time. It's gonna be the RNA. It's probably gonna use that on the DNA. Like it's probably initializing the curve stuff for the first time, and it's gonna put that somewhere so that it can show there the option. I think maybe. Oh, this one might be interesting. I'm gonna have to see next time because I lost where it is. Pretty sure it's not on this file. Whatever. Right. So is this counts? Trying to figure out what the list is there. This container RNA. And then there's gonna be once here. There's gonna be properties. And properties list space. Generic abstracted container of RNA properties. There's a linked list, I think. Next. So basically this property RNA is the thing that holds the information for the class. And that one is the one that is going to display there on the GUI. And skip over all of this stuff. So curve OT with a Bezier curve. And the question is where. So operator time. I'm trying to see where this stuff. I'm gonna see where the function is called from to see where what is the connection between this operator type and the rest of the things. Struct UI types. Blah blah. Blah. I'm just gonna skip this stuff. For reference. So the operator types curve. So it's very similar actually, I think, the way it works. I think this is on the I've seen this on the last string, the register core stuff. So Godot has similar functions where it's just gonna register all the types, and the way that Godot does it is to add on the class DB, which is a class, a global class that keeps track of all the classes for the project. So I think it's pretty something similar that is happening here. You're just adding all these types here for the classes. And these are related to the curve. It's probably this thing here. So this class is the one that keeps track of the things. And it's static. So it is pretty similar. So it's just using a global variable. Just gonna be this map here. I think this is a lambda function. Yeah, it's a lambda function that calls itself. This is like, I forgot the name, how you say the name for this kind of function in JavaScript, for example. Like it's a function that you declare and it calls itself automatically. But in C++, I think it's just a lambda. But I do think that this calls itself in the beginning there. And it's a global variable. So it creates this map. And this map is the thing that is going to keep track of all the operators. So it's like registering all the classes. So in Godot, the equivalent would be probably class DB. Class DB is the equivalent of this. And it's not object slots. Object slots is just to keep track of the each instance of the objects that are created, but class DB is to keep track of the types. So I think this is more analogous to class DB on Godot. It's just a global variable that is going to keep track of all the types. And then the functions that they're doing that are with the other structs with property RNA is just the thing that holds the information for the class, I think. Which is gonna be on this operator probably. So it has all this. So property RNA. So property RNA is probably is the properties of the class. So in Godot, I think that this would be method bind. No. Yeah, yeah, method bind. And the map is method map on Godot, I think. So each class has a method map, which is a map that keeps track of all the methods for the class. But I think it's different actually. It's property info. So on Godot, it's property info. It's a macro that keeps track of. It is actually a class, I think. Property info is a class that keeps that, and then you have add property macro that allows you to register the properties for the class on the class DB. So it's very similar here. I think it's basically the same logic. So let me go back. So I'm gonna try to, yeah, here I put, just gonna try to move on this. So I wanna see, okay, now that I know, I should have wrote down there. Fuck. So let me see if I can find again. I'm gonna write down the name of the global map there. It doesn't matter which one. So it's operator type, I think. Yeah, so this is the map. So it's on source, Blender, window, manager, return, operator. Yeah. So let me continue this stuff. So for each one is registering. So these are probably the main types. Space types. And for each one of them has a bunch of functions to register the types. We're just gonna skip over all of this. It might be, yeah, so I'm gonna go over one of them. Just adding more types. Let's see what this is. I think for now it's not that interesting. So let me try to get out of this. So space init here. And this is the main function there, the main init function. So now I don't remember if I put another breakpoints or those are the only ones that I had there. I'm just gonna press F10 and step over everything. And if there isn't any other breakpoints, I'm gonna try to interact with the GUI and see if it stops there. Yeah, the problem is that like there's so much stuff here. So and I think this is a mistake that I did on the other one. So because like the tendency is to try to figure out everything. So like I want to explore all the functions, but then it takes too much time, I think. So it's more effective to just go straight to what you want. So I'm just gonna skip, and then if I can't find anything, I'm just gonna keep looking. I'm gonna try to look for tooltips, and then yeah, basically try to find endpoints that allow me to put breakpoints that only trigger when I interact with the GUI. So because that way it becomes more clear, the mental model of where I'm at with the code and what's is happening on the what is supposed to be happening on the functionality of the GUI. So I think it's better to try to understand it that way. This RNA init might be interesting at some point. Basically, now I have more of a clear understanding. I think that the main things that I'm going to do is both this thing that of the UI that I talked about and look for the RNA and DNA files that are related to the curves to understand how they are built. Maybe I can look directly, I can try to find directly on those classes the function that is related to building the vertices. The annoying thing might be the data, like figuring out how the data is related, because it's gonna be dependent on the context there, I think. So yeah, to understand how to put the depth to the curve. I think those are the main points that I had there, and it's probably this one. Yeah. Oh, so don't say. So I'm gonna see what happens if I try to add here. Yeah, so it does stop here. I'm gonna skip over this because I think it is just getting the name there. This one I'm gonna go over. So this is the thing that is kind of annoying, is because it depends on the. So probably what I'm probably gonna have to do is just watch more tutorials and then write down the exact things. So I have to see if I can find the shortcuts. How do they do the shortcuts? Maybe I can ask ChatGPT. I'll also look into the documentation. because they're probably unknown the files there, like on these points here, and doesn't have anything. But I think it will be, it will make it easier to find. So I think at some point I'm going to do that. So let's type. I think this is probably the main thing. This one I already looked into. So it first initializes the object, then uses these values to create the matrices. So this is just calculating the position, the initial position of the object, I think. Just gonna be based on these matrices. So it passes based on this stuff here. And it gets from the object to roads pointer. So it's location and pointer it gets. Yeah. I'm gonna skip over these functions here. Maybe actually it's good to see. And probably this stuff related to shortcuts is gonna be somewhere with like close to the window. Yeah, because it's gonna be related to inputs. Inputs are gonna be related to the window, so it's gonna be something related to the window struct, I think. Trying to see if there's anything. Problem is that it's kind of hard to figure out from here, like information that is useful. It's just a bunch of memory addresses. Yeah, so I'm mainly interested in this thing here, but I think it's gonna take some time to understand how the values of the context are updated. So whatever. I'm gonna go over this stuff. Layer. Next time I'm gonna look at this. But so far, I don't think it is stuff related to the actually building the curve for the first time. As main scene view layer type. Type is Bezier curve, probably. Not sure. Name is Bezier curve. So the add data from type is gonna be the thing probably that creates the object. I'm gonna skip this. I think this is just gonna initialize the first stuff. Yeah, it just initializes the allocates memory and stuff like that. Initialize everything to 0 probably. And the other one is gonna be the one that creates the data, I think. So this one. Yeah, so here, so I'm gonna put a breakpoint here. Okay, object, up data, add from type. So it's on Blender. So I'm gonna write this stuff as well. Source Blender blends. No, blend kernel intern. Oh, actually, objects. CC. I'm just gonna copy here. So here's probably all the main functions in the beginning there. The thing that's gonna create the geometry, I think, for the first time. So I have the bmain, the name. Main is probably the class that holds the state. So the way that I think it works is that the main is gonna be the class that holds the state. That is a linked list. So that is related to the scene. I'm not really sure if there's a bunch of scenes. Maybe just one scene, and then there's a linked list of main, and then each main has the state of the whatever happened on that scene. And then the scene and the main, the main is connected to the scene probably, and the scene is connected to the context there. And the context controls the flow of data, I think. So this curve is the class. So just allocating memory. So I'm gonna write down this stuff here. So it's interesting that the thing that I have to figure out is whether or not this is gonna be a base class, but obviously I think it's gonna be easy to see based on the functions there. I think it's more composition, just based on this stuff about DNA and RNA. It's more of a composition approach. So it's just one class that is the curve, and then what differentiates the different types of curves is the classes that are going to be used as member variables of this curve class. They're going to change the way that the vertices are built. I think that's how it's going to work. Source Blender makes DNA curve type. So yeah, seems like it doesn't have any functions. So I think is the way that I'm thinking about. So this is gonna initialize the data for the first time. Hmm. But here it's just building the class and it doesn't have anything. Hmm. Yeah, that's kind of weird. So the only explanation is that it comes later. So that part just initializes the class, and then probably at some point, obviously, it has to put data here. So I think it's just initializing, like allocating memory on that part, and whatever exists inside of that struct there, which is the curve, is gonna be the stuff that is responsible for creating the vertices at some point. But obviously, based on this, it seems that it happens later. So maybe it's because it's like dependent on the context and the main and the thing. So I'm assuming that it didn't do anything yet to build. I want to skip these asserts. I also think that this layered is not gonna have anything that directly changes. I'm just gonna pass this. This one probably doesn't have anything as well. Blah blah blah. I don't think that these functions are actually the ones that are gonna build the curve. Maybe they are, but so I think that what this is doing is just building the sync tree. So it's a node tree. So they make it as this graph probably. So I imagine like if you have a bunch of things on the scene, then it's gonna be a tree. Either if you only have one, but it's a relationship between different nodes. And this is just updating the stuff that is related to managing that. So I'm gonna skip this because not interesting. I wanna see if I can find the function that this one might be the thing. It's the one that I was just looking. So I think I'm gonna skip this one. The question is that it's kind of tricky because the same thing happens on Godot and probably other code bases as well. Because sometimes like the name is kind of deceiving, and somewhere along the function there is some stuff that is going to be related to the thing. So like this is kind of the problem here is that, and the annoying thing is that you have to start over from the beginning. So I think that is worth it to just step into and then like take a look and just start to step over and based on the names there. Because it might be the case that I skipped accidentally the function that builds the thing, or it might be somewhere else that does it. So I don't think that this some hashing thing, but I don't think it's related to. So I think it's hashing to create like unique names inside of the graph that manages what happens on the scene. To probably cache like if you save the scene later, it's gonna use this graph and these hashes to save into a file, probably a cache file, to keep track of the state of the scene. So that next time you open Blender, it's gonna show the stuff there. I'm gonna skip this one. I'm gonna skip. I don't think that this is related. Skip. So this is the thing there. It doesn't seem that there is anything that is related there. So I'm gonna skip this one as well. Base. Anything that doesn't seem that is directly related to the thing, I'm gonna skip. So the layer stuff I think is related to something else. It's not the thing. Maybe this one is data pointer verifier. Oh fuck. I think I should step into this. So I'm gonna put a breakpoint here next time. I'll do this. But I'm not really sure if this is like it seems that it's updating the data for the context and not the object there, but maybe it is. I think this is just transformations of the object, but it's not creating the geometry. ID type. Maybe this is. So this is checking to see if it is on the edit mode there, because there's two different types there. And the edit mode is the one that allows you to change the points there in the curve. So it's getting this from the data. So it initializes this somewhere there, but I probably skipped this. Or it's just, yeah, it's checking to see if it's a null pointer. Or maybe it didn't skip and it's just like if you cache. Yeah, but I probably skipped somewhere, but doesn't matter that much. So it might be possible that I already skipped the parts because it's checking for data here, so this is the challenging thing, is figuring out where the data is in the beginning. And not fire. So here I'm gonna be able to. So yeah, it has this, but it looks like everything is empty. So it's just zeros. So it wasn't initialized probably, I think. Because this is supposed to be the data on the object. So this is all empty. So I think it wasn't initialized yet. So I think that what this is doing is trying to find the type. So remember that it mapped everything on that thing there. So I think based on the type, it tries to find on the map, the global map that it uses there to see if there is already an object like that, I think. or something along those lines. It's mission could be added in edit mode even if there was no animated data. So this is going to be for animation. Shape key to new nerves of edits, not those of the original curve. And after regenerate key index of valid original data to properly restore curve when leaving edit mode. Yeah, so no is a no pointer. It doesn't have anything. Also no pointer. I'm gonna skip this as a hash. So it creates a hash there at the beginning. I'm gonna skip this. It's probably gonna be related to events, so at some point I'm probably gonna resolve. So it's probably this stuff here that they are using for events. Notifiers. But I don't think that these ones are the ones for shortcuts. Maybe these ones. Yeah, so these ones are probably the events. So maybe it's worth to write this down and then so I can look it up later. Number operators. Strong show. Yeah, I'm gonna look into this file later. But I think that is this file that has the enums that are gonna be used to figure out what keyboards what keyboard letters or like patterns were used to determine the functionality there. So I think it's related to the whatever is happening here. So this, drag and drop. So I'm gonna write those down for later. Source, Blender. So let me keep going here. Thing was, it might be on one of these graph classes or one of these graph functions that it does the data for. Really getting tired, so this one. Just gonna try to go fast to see the whole flow of things here. Should maybe figure out like to narrow the search of where it might be. So it might be here, I think. I'm just gonna. So this is the part that I put the breakpoint there. I'm gonna go try to go fast. See, this is just the matrix stuff that I looked into. Add norms. Maybe this is the one. Let me look at you. Not fire. So it's either this or this, I think. That is gonna initialize the stuff for the first time. Blah blah. So is this function here? So I think depending on what kind of curve it generates different points. And it's based on these vectors. So if I have the Bezier, so this is the circle, 5-point path, curve. So if you select the Bezier curves, this stuff here is gonna be on this thing here. So it's based on this, so it allocates memory here, probably the same way that we do stuff, down. So you're gonna hold information inside of this thing, and then on the vector of this thing. Well, inside of this thing, they have these other bins, triple stuff here, and then inside of this thing, they have a vector. Then on the vector, they generate the math for creating the Bezier curve, I think. So probably, so they're gonna create this vector, which is probably a matrix representation, just based on this stuff here, which creates the shape of the curve based on the numbers I have here. They probably translated like the math equation to create a Bezier curve into this structure here, which is going to hold the information on the vectors. And then later on, they're going to use this this NURB thing here, when I change the depth there. So I do think that I put the breakpoint there on the depth. So now, I'm gonna write this down. So I'm gonna stop here because I'm already tired. So, but I'm gonna continue at some other points from this point here. And basically what I'm gonna do is just get this. So I'm gonna see which one it is that they are doing, and then I'm gonna try to extract this like into another class, like create another class on another project, then put this, see how they build this vector, and then create the same data structure outside. And then once I do this a couple of more iterations to see the whole flow of how it adds the curve, then so I want to clarify the whole flow to add the curve for the first time, and also the breakpoints for what happens when you change the shape of the curve, just to make sure that I have the right idea of how the vector is going to be manipulated when you add more control nodes and change the shape overall. Because basically, I think that it's going to be like that. So they use the vector as the data structure that has a shape, and then the other part is going to be to analyze the depth. What happens when you put depth? Because the depth, I think, is going to be also related to shaders, but obviously it's going to be. I think that's the main thing that I have to figure out. So I think from this simple data structure here, they are going to use the depth to create or to change the state either of this or create another data structure that's going to have the floating point values, I think, that are going to represent the points of the curve on with the depth. And then they're going to use this final data structure to, at some point, use a shader to update the, or to create a visualization. So yeah, the thing I guess this is another point, but I'm not sure how difficult it's gonna be. It's like at one moment they send this data to a buffer so that they can use on the shader. Because the final structure that they use on the buffer is the one that obviously I'm gonna need because I'm trying to do the same thing. And then if I can find that point, then it becomes a lot easier because then I can just get that data structure and I can go over this cycle several times. Yeah, having that structure in mind, just see what's going on for them to build and change the state of this structure to build the vertices. And once I get that very clear, then I can translate that into the other stuff, I think. So I'm gonna write down the name of this function and put a breakpoint here. I already have the breakpoint there. So it's gonna be on source Blender. I'm gonna create another file to keep this stuff here. Another file there on the projects that I have. So I don't mix with the Godot stuff. I'm just gonna copy. So I'm gonna create on the same folder that I have this file here. I'm gonna create another file and then just put this stuff related to Blender. So I'm gonna stop here. Next time I'm probably gonna continue to go over this code here. And I'm probably gonna spend some time off stream as well. No, but probably tomorrow, I think. If I don't come back tomorrow, then 2 days from now. And I'm gonna continue from this point here. And the goal is to translate the 3D curve from Blender to Godot. So get the points from, get a vertices and whatever other information I can get from Blender. Then create an algorithm that takes 2 points, creates a Bezier curve, and then puts depth on the Bezier curve, and then try to use that algorithm on Godot. So that's the goal. So yeah, see you next time.